So
It's not recording. Oh, no, it's recording.
give a little space there. With enthalpy, things want to be exothermic. Exothermic is a good thing, giving off heat. You don't want to have to put heat in. And with enthalpy, heat, remember, right? That's what enthalpy stands for, is that things want to go from hot to cold. Okay? That is a law of nature. Things go from hot to cold. If you put a hot glass of tea out, it cools down spontaneously. If you put a cup of water out, it doesn't just heat up on its own. You don't come back a half hour later and you're like, oh, my cup, it's hot. Okay? Things go from hot to cold. Similarly, another driving force in the universe is entropy. And entropy is a measure of disorder of a system. And what this means is that systems go from order to disorder. Your bedroom is a classic example of this. Your bedroom naturally goes from order to disorder. Your bedroom does not spontaneously go back to order. You don't come home, Kylan, today and you open up your door and all of a sudden the pants jump off the floor, fold themselves up and jump in the drawer. Okay? That doesn't happen. Except for Jimmy Neutron. But for most of us, it seems like our rooms just get messier and messier and messier and messier. Okay? Everything is going towards disorder. Now, unlike enthalpy, you remember Enthalpy Mountain where there's no bottom and no top? With entropy, there is a limit, a bottom limit, to the disorder in our system. Okay? Like, just out of curiosity, who's got the messiest classroom of your teachers? Is it me?
You.
Okay, so I have a very high disorder. Who's got the most organized classroom?
Mr. Werger.
Okay, Mr. Werger. So Mr. Werger would be the standard, okay? He would be an entropy of 0. Perfect order is Mr. Werger. In chemistry, we say crystals at 0 degrees Kelvin are perfectly ordered. And have an entropy of 0 joules per mole Kelvin. Entropy is measured in joules, not kilojoules. This is called the third law of thermodynamics. I know we kind of skipped the second law, but we'll come back to the second law. The third law of thermodynamics is crystals at 0 Kelvin are perfectly ordered, and therefore they have an entropy of 0.
Does Kelvin have a degree sign, or is it just?
No, it doesn't. Why does Celsius and Fahrenheit do and Kelvin doesn't? I don't know. It's one of those mysteries that have always plagued me. Okay, let's take that equation we did before. We've got aluminum plus iron oxide going to 2 irons plus aluminum oxide. We calculated the delta H of the reaction already. What's up, Mike?
call me when.
Sure, sure. Okay, so aluminum is 0. Iron is 0. Iron oxide, we said, was -824. And aluminum oxide was -1676. So we calculated the delta H of reaction by doing products minus reactants. And we came up with our delta H of reaction to be -852. And we said it was exothermic. And that's good. We like things to give off heat. Well, we have this other driving force in nature called entropy. Things want to go to disorder. You're going to calculate the entropy of the reaction the same way as you calculate delta H. The letter for entropy is S. So S stands for entropy. We're going to do the exact same thing, except now we're going to use entropy values. And so if you go to your appendix N, you'll see a column that says S. Those are entropy values. The one thing you want to remember is that entropy values are in joules. So I write down my S values just like I did with enthalpy. Aluminum is 28. Iron oxide is 87. Iron is not on my sheet, but I can tell you it. Iron is 27. And aluminum oxide is 51. So we calculate the delta S of the reaction the same way as we did with enthalpy. So we do our products minus our reactants. So our products are iron. We have 2 moles of it. So 2 times 27 joules per mole Kelvin plus 51 times 1. And then we subtract our reactants. 28 times 2 and 87.
What does it say? Does it say 2 joules per joule? No, one on
The very first one.
Yeah.
2 times, oh geez, sorry, that should be 27. So if you calculate it and you add it up, it comes out to be got it here somewhere. 27, I think. Now we better do it quick. With a -10, okay? 1 second. So that's joules per mole Kelvin, okay? We'll talk about what this means on Monday. Do that final
Tuesday.
review. I'm sorry, Tuesday. And then I want you to finish reading chapter 27, okay? Finish reading chapter 27. Have a wonderful weekend. Don't forget your homework.
38.
38.
105 minus 143.
Oh, I forgot to multiply by 2. Yes, you are right. Thank you. A what? Sure.